Good day, everyone. I am Jezica Gannaban, your discussant for the topic Trigonometric Functions Integrals. Here are the following objectives. At the end of the lesson, the students should be able to recall trigonometric identities, identify the integral of trigonometric functions, and solve for the integral of trigonometric functions. Here is the list of the trigonometric identities. We have reciprocal, Pythagorean, quotient trigonometric identities, cofunction identities, sum and difference of angles trigonometric identities, and double angle trigonometric identities. These identities are useful in our topic, especially if there's no direct substitution from the formula of integrating trigonometric function. First on the list is the reciprocal trigonometric identities. We have sine theta equals 1 over cosecant theta, or cosecant theta equals 1 over sine theta. Cosine theta equals 1 over secant theta, or secant theta equals 1 over cosine theta. Tangent theta equals 1 over cotangent theta, or cotangent theta equals 1 over tangent theta. Next, we have the Pythagorean trigonometric identities. We have sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. Cotangent squared theta plus 1 equals cosecant squared theta. We also have the quotient trigonometric identities. We have tan theta equals sine theta over cosine theta, and cotangent theta equals cosine theta over sine theta. Next, we have the cofunction identities. We have sine 90 degrees minus theta is equal to cosine theta. Cosine 90 degrees minus theta is equal to sine theta. Cosecant 90 degrees minus theta is equal to secant theta. Secant 90 degrees minus theta is equal to cosecant theta. Tangent 90 degrees minus theta is equal to cotangent theta. And cotangent 90 degrees minus theta is equal to tangent theta. We also have sum and difference of angles trigonometric identities. We have sine of A plus minus B is equal to sine of A cosine of B plus minus cosine of A sine of B. And cosine of A plus minus B is cosine of A cosine of B plus minus sine of A sine of B. And we have tangent of A plus minus B is equal to tan of A plus minus tan of B all over 1 plus minus tan of A tan of B. Lastly, we have the double angle trigonometric identities. Sine 2 theta equals 2 sine theta cosine theta. And for cosine 2 theta, we have three forms. Cosine squared theta minus 1, 2 cosine squared theta minus 1, and cosine 2 theta is also equal to 1 minus 2 sine squared theta. Tan 2 theta equals 2 tan theta over 1 minus tan squared theta. Integration of trigonometric functions involves basic simplification techniques. These techniques use different trigonometric identities which can be written in an alternative form that are more amenable to integration. That's why we recall our trigonometric identities. So the integration of a trigonometric function f of x is given by f of x, and it is represented by the integral of f of x with respect to x equals f of x with capital F plus c. The right-hand side of the equation means the integral of f of x with respect to x. F of x here with capital F is the antiderivative or primitive. F of x is the integrand, dx is the integrating agent, c is the constant of integration or arbitrary constant, and x is the variable of integration. Our focus in this discussion is the integrals of the six trigonometric functions. We have the integral of cosine x with respect to x is sine x plus c. The integral of sine x with respect to x is negative cosine x plus c. The integral of secant squared x with respect to x equals tangent x plus c. The integral of cosecant squared x with respect to x is negative cotangent x plus c. The integral of secant x tan x with respect to x is secant x plus c. Lastly, the integral of cosecant x cotangent x with respect to x is negative cosecant x plus c. Integration is just the inverse of differentiation, as you can see on the screen. Now let's put them into practice. We're going to solve for the integral of the following functions. First example, we're going to get the integral of 3 sine x with respect to x. If you look into our formula, the integral of sine x with respect to x is negative cosine x plus c. But there is a constant multiplied in the function x of the given example. In here, we can use the constant multiple rule of integration. Applying it, we have 3 integral of sine x with respect to x. Now we can use our formula for integral of sine x with respect to x. So we have 3 times negative cosine x plus c. Simplifying this, we have negative 3 cosine x plus c, final answer. Next example, the integral of the quantity 5 sine x plus secant squared x with respect to x. Applying sum and difference rule of integration, we can take their integral separately. So we have the integral of 5 sine x with respect to x plus the integral of secant squared x with respect to x. Again, there's a constant multiplied in our function x, so we can apply constant multiple rule here. We have the 5 integral of sine x with respect to x plus integral of secant squared x with respect to x. Now we can use our formula for the integral of trigonometric function. We have 5 times negative cosine x, the integral of sine x with respect to x, plus tan x, which is the integral of secant squared x with respect to x. Simplifying this, we have negative 5 cosine x plus tan x plus c, which is the final answer. Third example, the integral of cosine squared 5x with respect to x. In here, we don't have a formula for cosine squared x, but then we can use our double angle identity. We have cosine squared a equals 1/2 times the quantity 1 plus cosine 2a, or just the same as 1 plus cosine 2a over 2, wherein a is 5x based from the given example. Applying it, we have the integral of 1/2 times the quantity 1 plus cosine 2 times 5x with respect to x. Next step, we're going to apply the constant multiple rule and sum and difference rule of integration so we can integrate each term. Applying it, we have 1/2 the integral of 1 with respect to x plus the integral of cosine 10x with respect to x. To integrate cosine 10x, we're going to use 1 over k sine kx plus c, wherein k is 10. So doing it, we have 1/2 times the quantity x, which is the integral of 1 with respect to x, plus 1 over 10 sine 10x plus c. Simplifying it, we have x plus 2 plus 1 over 20 sine 10x plus c. Therefore, the integral of cosine squared 5x with respect to x is x over 2 plus 1 over 20 sine 10x plus c. Number 4 example. This example involves an even power of tan. Okay, so we have the integral of tan squared 3x with respect to x. Here we can apply the Pythagorean trigonometric identity. Tan squared a is equal to secant squared a minus 1, wherein a is equal to 3x based from the given example. So let's rewrite the integral of secant squared 3x minus 1 with respect to x. Integrating each term by applying sum and difference rule, we have the integral of secant squared 3x with respect to x minus the integral of 1 with respect to x. To integrate secant squared 3x, we're going to use 1 over k tan kx plus c, wherein k is equal to 3. So the integral of secant squared 3x with respect to x is 1/3 tan 3x minus the integral of 1 with respect to x is x, and then plus c. Therefore, the integral of tan squared 3x with respect to x is 1/3 tan 3x minus x plus c. For our last example, we have the integral of 3 cotangent of x minus 5 sine squared x all over sine x with respect to x. First, we can integrate each term having the same denominator, which is sine of x, and we're going to apply constant multiple rule. So we have 3 integral of cotangent of x over sine of x with respect to x minus 5 integral of sine squared x over sine x with respect to x. Next step, we're going to separate cotangent of x to sine of x so that we can apply the trigonometric identity. If you can recall our trigonometric identity, cosecant of x is equal to 1 over sine of x. Okay, so we have 3 integral of 1 over sine of x times cotangent of x with respect to x. And then just copy minus 5 integral of sine x with respect to x. Now we can substitute 1 over sine of x with cosecant of x. So we have 3 integral of cosecant of x, cotangent of x with respect to x minus 5 integral of sine of x with respect to x. Now we're going to apply the formula for the integrals of trigonometric functions. So we have 3 times the integral of cosecant of x, cotangent of x with respect to x is negative cosecant of x, minus 5 times the integral of sine of x with respect to x is negative cosine of x plus c. Next, we're going to simplify this. So we have negative 3 cosecant of x plus 5 cosine of x plus c. We can also rearrange this. So we have 5 cosine of x minus 3 cosecant of x plus c. Therefore, the integral of 3 cotangent of x minus 5 sine squared x all over sine of x with respect to x is 5 cosine of x minus 3 cosecant of x plus c.